Hello everyone. We're going to take a look today at a few changes that have been occurring in Augie. It's getting very close to the time I'm going to hook up my laser and we'll start calibrations and so on. You've seen videos that my motors are moving quite nicely, so it was time to work on the output circuit. To that end, we have a firing circuit on our screen here where I can push a fire button and fire a PWM test. This test propagates through the whole system and is a real test of the real-time PWM. In order to run it, you have to activate an M3 to turn on the spindle. I can do that over here in my single line MDI just by operating an M3 with a single line. And if I then push fire, you can see this laser on light fires for the length of time entered in my time in milliseconds. And what it's doing is firing a PWM pulse out for that length of time at the power that's provided. Now, in order to add this to the system, I found that it was kind of awkward for a user to add scripts. So we've really done a great deal of work in not only stabilizing the system, there's been a tremendous amount of debugging that's gone on in the last week or two, but we've also made it easier for a user to attach their own buttons and controls to the system and to script them at will. And the test fire circuit is an excellent example of that. So we'll take a look at how that was done. Now, let's start from the beginning. I knew that I needed a slider and a power DRO so that I could select power from 0 to 100%. So to do that, I simply dropped a slider on the screen. I set its minimum maximum at 0 to 100, and I gave it a variable name called laser power. I then put a DRO on the screen and gave it the exact same variable name. And that's the reason I point this out is that if you give two objects the same variable name, they automatically link. As I move the slider, the DRO, because it's the same name, shows that same value. And if I take the DRO and enter a number into it and hit enter, you can see the slider goes to reflect its value. This is a powerful way of connecting objects on the screen. If I was to then add an LED on top of that and give it the same variable name, it would be lit until the power hits 0. At that point, the LED will go off because LEDs only understand that they're 0 or not 0. Anyway, that's how you can link commands together. But then we needed a DRO for time. Well, of course, that's easy. You could just enter one on the screen and give it whatever variable name you like. The same thing with this fire button. The fire button is simply a button I put on the screen. I told it that it was not a toggle button, so I want a message both when I push and when I release, and I gave it the name fire, and I also gave it the label name fire, but its variable name is also fire in capital letters. So let's take a look at how I would deal with that. I'm going to open up the scripter to make this easier on people's eyes so they're not looking at really small text. And let's turn it on. Now, when you turn on the scripter these days, you'll see mine comes up busy with text, and it's just simply a script that I'm working on. When you shut down the system, whenever you power off the scripter, it remembers what text was in it, and it saves it to disk, and the next time you power up your debugger, you'll find that you're being presented with text that you're working on. And this is a good way that you can sort of scratch pad your way through a program without having to worry about saving it and so on in libraries each time. So I'm going to open up a library. And the one that I want is in the G-code library, and it's this spindle live laser. This is where I've put my commands. And you can see if we look in the functions, we have spindle on, spindle off. These are function and spindle speed. These are functions that are called by the G-code library, which we've talked about in an earlier video. But then we have two new functions, test fire and fire. And you'll see that this one command, fire, is fire in capital letters, which matches the button. That's all you need to do to create a script which is run by a user. Create a control on the screen, give it a variable name, and then just simply create a script of the same name. So let's do a local edit on this so we can see how that's done. The text that I was working on has now been shunted to the side and will be brought back when I check in this library. Make sure you remember to check your library back in, or you will lose the text of whatever script you were working on that had been saved for you across the shutdown. Alright, so I'm going to take us right down to that fire script. Here we have global fire is equal to function, and I've got a parameter turn on. If you make a script for a button or for any control, you'll get one parameter that is the current state of the control. So this word turn on will be a 1 when I'm pushing a button and a 0 when I release it. If this was a script that was tied to a slider, you would get a position. instead of an on or an off signal. So it's intuitive what you get when you make a function like this. So I've created a function called fire, and I've given it a warning. If the spindle isn't on, give the person a message and then exit out of there. That's just a safety to make sure we don't try to fire and then wonder why we didn't get a laser on light, which I'll explain in a moment. And then it's very simple script. If turn on, we just call a routine called test fire for the time and the power provided. To get the time and the power, you'll see here I have time is equal to global get fire time. Well, if I right click on the fire time DRO, you can see its name is fire time in capital letters. So it's pretty easy to get a value that you've created. Now we've got laser power is equal to global get laser test power. And both the DRO and the slider down there are set to the name laser test power. So they link together by having the same name. They control each other, and you as the user can get that value with the single laser power is equal to global get laser test power. We then send a message to the user that we're going to test fire, and we tell the system to test fire for that time at that power. It can be turned off early, however. If you release the button, this same function will be called with a 0 up here, which will cause us to call test fire 00. And here's our test fire function, which uses spindle control, our variable that points at a poke keys. You remember we have spindle control is equal to motion. So we call that variable's routine called test fire real-time PWM, which is a system function that's attached to the core. So this entire firing network consists just of these two small scripts and a few buttons that we've dropped on the screen. Now I'm going to turn off the scripter here, and we'll go back and look. And you can see when I push the button for a second, the laser light comes on for a second. If, however, I push and release it, the light comes on and off immediately. This laser on light is tied to a system variable which monitors whatever PWM channel is currently set for laser on. It checks to make sure that no laser on commands are going through, and it will be tied into the e-stop circuit, so if any radiation is sensed when you're not commanding it for one reason or another, it will shut off. Anyway, that's just a couple of the changes that have been made to make things easier. It's probably not far away before you'll begin to see videos of lasers firing and cutting calibration sequences and so on. I'll end this video by showing you a picture of my control box and what happens when I push the test firing circuit. You'll be able to see the PWM firing on the scope that I have built in. So let's take a look at that. So this is what my control looks like now that it's been rewired. You can see in the photograph there is a Pokeys 57 CNC, but there's an oscilloscope attached in the upper right hand corner of the cover above a Raspberry Pi and an Arduino. Let's take a look at that scope during shooting, and we'll be able to see the firing sequence itself. So this is what my system looks like as it comes up. So let's zoom in on the scope, and we'll be able to see now there's a couple spurious pulses that just went by. We're looking for the source of those now. But there's what happens when I push the test fire button. You can see that it fires for the length of time that I have it held, and there's about an 80% PWM shot. So that's what goes out to your controller. Anyway, that's verification of PWM. We're going to hook up the laser very shortly, and then we're off to the races. Have a good day.